Hello everyone, I'm Vincent Racaniello, host of the science show This Week in Virology. For this special episode of our podcast, we've been given the opportunity to tour the NEIDL, the National Emerging Infectious Diseases Laboratory, which is part of Boston University. This newly constructed facility contains laboratories with 3 different levels of containment, BSL-2, BSL-3, and BSL-4, the last 2 for working with the most dangerous pathogens. We were given the opportunity to visit the NEIDL because its BSL-3 and BSL-4 laboratories are not yet operational. The NEIDL was built in Boston's highly populated South End neighborhood, and there has been community opposition to its opening. Since its construction in 2009, the NEIDL has faced a raft of legal and regulatory hurdles that prevented it from becoming functional. The silver lining of this cloud is that the TWIV team was able to visit the facility. In this special episode, we'll tour the NEIDL with Associate Director Ron Corley and Elke Muehlberger and Paul Dupre, virologists who'll be working in the facility. I'll be accompanied initially by TWIV host Alan Dove, and Rich Condit will join us later in the tour. We'll take a look at how the NEIDL is secured from unauthorized entry, how the facility is constructed to make it safe, and how workers carry out experiments with highly dangerous viruses such as Ebola virus and Lassa virus without jeopardizing their health. Alan and I start our tour of the NEIDL by meeting up with Ron and Paul outside the laboratory. Hey Paul, how you doing?
Welcome.
Good to see you.
Very good to have you here.
This is my TWIV co-host, Alan Dove.
Alan,
Good to
heard
meet you,
you,
Paul.
never met you.
Paul Dupre is a virologist here at BU, Boston University.
And you don't know Ron?
No,
Ron's
we haven't
the
met.
chair of
Ron Corley.
microbiology.
Vince Racaniello.
Nice to meet you. Alan Dove.
Alan,
good to meet you too.
What are we doing here today?
Yeah, we're going to look at NEIDL. We're going to look at some of the science that we want to do in the place. We're going to talk about some of the security, some of the safety measures in place to make this place work.
Okay,
So we'll go inside.
great.
Good.
So Ron, this looks like a first level of security. What are we doing here?
Yeah, so anybody who has access to this facility first has to go through an iris scan. That's the first level that gets you into it. So all these are dual iris scans.
Thank you.
And when you've been recognized and you're in the system, then it opens the door for
And
you.
it scans both eyes.
Scans both eyes. And we are told that it does not work on dead eyes. So Paul and I both have scanned in, and we're escorting you, so
And this is like an airport scanning procedure.
like an airport scanning procedure where you have to have any bags scanned, anything in your pockets checked out.
And back through? Okay. Great, thank you.
So what do we do next, Ron?
Well, let's go out and take a look around the building first. I think it's easier to get a sense of the security features by taking a walk around.
Great, it's a
And
nice
you
day
get-
too.
Ah, it's fantastic. It's a good thing it's not pouring on us.
We'd have to film anyway.
Yeah.
So Ron, this is unusual. The building is in the middle of Boston, yet there's a lot of space around it. It's set back and there's quite a fence. What's that?
Yeah,
for?
you're absolutely right. It's one of the regulations of a building that's been built with federal funds requires that this building follow U.S. Embassy standards. So there's a 150-foot setback, there's a perimeter fence, there are protections to keep any vehicles or people from entering. And as we walk around, we can look at some of those.
I noticed on the front of the building there's also a huge grill, like this one, on the front of the glass part, which we see here. On the other side there are also grills, I presume?
Exactly, yeah.
So why so many grills?
That's vent space for air handling.
So does this building have greater air handling requirements for a standard building?
It actually is one of the biggest expenses in this building
Okay.
is the electrical bills and the air handling, particularly for moving airs through containment spaces, level 3 and
Okay.
level 4.
Because that's how it's all made safe.
Right.
Right.
You know, lower pressure and lower pressure and lower pressure. So the air always moves in the direction of a safe HEPA filter. So none of the air comes out of that BSL-4 space without having gone through these filters. And how do you control air? You control air by pressure, hence all of the different layers of air handling space in the building.
So the HEPA filters filter the air coming out of the facility, and that will remove bacteria, viruses, anything that might constitute any kind of risk, right?
Right. Safest, most efficient way to remove particulates.
Yeah, one of the things people like to hear, this is not all new technology.
Right.
All right, can you now show us some of the perimeter securities in place?
Yeah, so let's walk over to, well, let's walk here first and you can kind of get a sense of it, because one of the things that you have to be able to do anytime you have this setback is this fence has to be impervious to anybody who would want to try to drive a truck through it. So it's all designed to withstand a blow from a 15,000-pound truck at 55 miles an hour. I believe that's the embassy standard. Over here you'll see these bollards that will prevent the trucks from coming through.
Let's go.
All right, so you see the bollards out there, that's the 150-foot setback, and this fence is not really a structural fence right here. This allows us to have this park that's been put out just as part of the things that have been done for the neighborhood.
So what would prevent someone from climbing over the fence?
So this fence is all rigged with indicators. There's wiring that goes through it that picks up vibrations, and that sends an alarm to security.
So if someone did try climb over and reach the grass, they would be
They'd already know, and they'd have cameras on them. As you can see, there are cameras all over this facility, and you can get every area around this facility on camera. So there's a second gate on the back side of the property. Let's walk over to it.
All right.
That's where vehicles go through.
So Ron, this looks like a serious fence here. What's that for?
Yeah, so this is the vehicle entry location. So you've already seen the pedestrian gate. That's where people come in. This is where any trucks that are delivering or removing any waste come out of this facility.
So on the outside there's a wire. What happens with that?
Yeah, so this is all designed to make certain that as a vehicle comes onto the property, the vehicle can be locked in place while it's being inspected to ensure that the drivers are the ones that were supposed to be driving the truck, and so the truck can be inspected to make sure that they have the deliveries that they're supposed to be making. And so the way this works is this fence line goes, this fence drops down, allows the truck to go on. These ballards that are out here in the front would come up and prevent it from moving forward, and that way it could be completely screened by security before it's allowed onto the property.
Now, if you have a fire and the fire truck has to get in, they have to be screened?
They do, and but in addition to that, they've already been through extensive training on the facility. They've done this multiple times, both with police, first responders, EMS first responders, and fire. And so they're feeling quite comfortable, I'm told, with the organization and being able to get onto the property.
So we've seen a pretty impressive security feature for pedestrians and for vehicular traffic, and the perimeter is quite secure on this facility. Maybe now we could go inside and start to look and see what is actually in this structure.
Yeah, that'd be great. And you'll also get a sense of what the layers of security are within the facility as well.
Great, let's do it. I wonder if we'll find Rich Condon in here.
I hope so.
Why?
Well, isn't he supposed to be meeting us?
Yeah, he is.
Hello. Finally.
Speak of the devil. Hey there, Elka.
Hi, Rich.
Remember
Nice
me,
to see you
Vincent?
again, yeah.
Very good. Hey, Condit, how are you?
Good to see you.
Okay, nice to meet
You know Alan Dove here?
This is the first time.
Rich,
First
good
time
to meet you.
First hour. Good to meet you, Alan.
Ron Corley, good to
Ron,
see
good to
you.
meet you.
And for those of you who don't know Elka, Elka's a virologist working on BSL-4 viruses, particularly filoviruses.
Cool. You can tell us all about it, right?
Yeah.
Viruses in the world.
The most important after polio.
No, I told you this week.
More cases of polio than Ebola, right?
But the vaccine available, so no issue anymore.
Oh, we can have this debate later.
Exactly. Let's go.
Sure.
All right, here we are.
Okay, to get entry to the lab, you have to go through the iris scanner, which hopefully will work. Yes, it does. Very reliable. And now we are in.
One requirement for a BSL-4 laboratory is that it has to be a separately engineered space. This is not only for earthquake protection, but for decontamination. The BSL-4 laboratory is a separate concrete building that was poured inside the NEIDL. Its walls are 12 inches thick, and the floor is 16 inches of heavily rebarred concrete. The NEIDL building is embedded into the bedrock, while the BSL-4 sits on top of the bedrock. That allows the two structures to resonate at different frequencies during an earthquake. A spacer between the two buildings allows for flexibility during movement. The pilings that support the building are within hollow beams in the hallway. When the BSL-4 is decontaminated, the rooms are filled with vaporized hydrogen peroxide or formaldehyde, and the walls have to be constructed to prevent any of that material from leaking into the corridors. The BSL-4 surfaces are coated with multiple layers of an epoxy resin that makes it easy to clean. So Elke, can you get us into this facility?
Well, sure. So the first thing is that we have to sign in here, so just to show that we are in the lab later on, and then we get our cups, which are here. So now we are ready to go.
Okay. Nice socks. All right, Paul, what do we have here?
So this is the change room. You have
Change room, right.
You've got your socks from Elke,
All right.
scrubs from Elke, and you bring in your outside clothes, your watch, all of this.
That
the
comes off,
only
right?
thing that you are able to bring in with you is your glasses.
My chain I take off too?
Chain off, watch, rings, everything.
All right. So then I put this on, and where we're going to go through that door?
Yeah. So
And
you go
what's in
through
there?
This door, and this is the interchange room.
Okay.
This is the personal body shower.
So then I'm in these, I will go in the suit room, and there the suit would go over the scrubs.
Suit goes over the scrubs.
So then once you've put the suit on, you would do your work, and when you are finished, you come back to the suit room, and then you go through a different shower. Is that correct? And then you shower the suit.
So
Is that right?
once you're in the BSL-4 space, the only way you can get out wearing that suit is to go through a chemical shower.
Can't wait.
Yeah, it's good fun, you'll like it.
All right, so right now I have to put these on.
Right now you have to put these on, and then you get to decide whether or not you want to let the camera
I
film
think
you or not.
we need to stop the camera.
Sure.
Because this is not pretty. All right, we're scrubbed up.
Ready to
Looks
go?
pretty sporty, right?
Okay. Small is good.
One thing, Paul, most of the rooms in this place have cameras, but not this one.
Not in here,
good.
and not in the suit room
Very
either
good.
as well. Okay, so you're scrubbed up,
Right?
and now we're ready to go into the simulator.
Okay,
To
let's
see
do
what
it.
it's like to wear one of these things.
Got it.
After you. So through the body shower,
Right?
and then
This is
into
our
the
simulator.
suit.
Yeah. All right, Paul, we're in the suit room.
And
How do we
here
do
we are.
next? What do we do next?
Well, first of all, you have to meet John Tonkus.
Hey, John.
Vincent,
Nice
how
to
are
meet you.
Nice to meet you.
John is responsible for our didactic training, so we learn all about the suits. He's going to tell you a little bit about that now.
Right.
And then what we're going to do next is put one of the suits on, let you try out what it's like to wear one of our high containment
Okay.
suits.
So I'm scrubbed. What do I have to do next?
Well, Vincent, first thing I notice is you're not taped. You haven't taped your
All right.
socks. Your colleagues show you the way here.
Right.
So we
Tape
use
up.
this tape. We use a different tape on the gloves.
So what's the purpose of taping?
The purpose is comfort. Socks will tend to typically walk off your feet if you're in a suit. So you don't want to be in a suit and have this bunch right at your toes.
And do I need to tape my mouth as well?
No, we would like you to talk. Okay, very good. Well, I just want to say a quick word about the training in general. Normally there would be prerequisites, medical clearance, there would be clearance for security purposes. BU does their own, and then because you're going into BSL-4 and you're going to be handling agents, you would have security risk assessment clearance also. But today we're just going to shortcut that a little bit. I'm going to give you a little taster of the didactic training, what the suit's constructed of, why we even wear them in the first place, and then hopefully we can get you taping and testing the suits and get you into them.
Sounds great. Let's do it.
Okay, so In terms of didactic training, we normally show the suit. First of all, within the classroom, step by step, where does the air come from? How does it get into the suit? I believe you've already been up on the mechanical space.
That's right.
So you've seen the 3 big compressors.
Correct.
Right.
We only need one of the compressors to actually supply all of the suits, but we have a lot of redundancy because it's such a critical system. The air comes down via these pipings and in the hoses. The hoses have these connectors on, as you see.
Right.
So you pull the collar back. In order to connect them, and I'm going to walk over here to one of the suits. You pull the collar back on the female end, introduce the male end, and push it in, and air is flowing into the suit. The air upstairs goes through a quality control, which is HEPA filtered and dried, but it also goes through a HEPA filter into the suit. Once it enters the suit, there's a distribution system, and you'll see all the hoses emanating from that distribution site. There's one area that's indicated with an arrow. This goes to the head, and 60% of the air goes to the head. That helps with avoiding the fogging. It gives a CO2 wash, and it also cools. The hoses that go to the arms and the legs also serve as a cooling function. Well, there are many other things that we would tell suit trainees about the suit. But one of the important things we want to get to is to show you how to integrity test the suit. As you see, it's fully encapsulating when the gloves are attached. So it's important to know that we have no leaks in there. It's a positive pressure suit, so if there were to be any small holes, air would carry away from the suit. But we want to know that it's got good integrity before we put it on. In the interest of speeding this up a little, some of the preliminary work has been done. So the vents, the exhaust vents, have already been taped up. The exhaust vents, obviously, when air is in the suit, allow for air to leave the suit. It's a one-way valve, so air can leave but not enter. So it's important those get taped up for when we inflate the suit. This zipper is like a frogman's outfit, so it seals gas tight. So now we have a fully sealed suit, hopefully. So we inflate the suit. It's important not to overinflate the suit. You don't want it to go bang. Okay. So now you have it fully inflated. What we would do is we would feel for any air escaping. There are 2 vulnerable areas, maybe 3, on the suit. One is the suit gloves. One is the seams around the visor, and the other are the feet. I'll talk about that shortly, but we have boots that we put on, and so the feet tend to be a little vulnerable. This seems to be good. I don't hear or feel any air escaping. You can put a slight amount of pressure on it.
Now, would you do this test every time you put on the suit?
We do the test every 7th entry or once a week, okay. But we would always visually check, especially the gloves and the feet.
Yeah, so if you found a hole in the suit, a small hole, what would you do?
Yes. If you find a very small hole, it's okay to do a repair on that, and that would just be put tape inside the suit and also outside. Mm-hmm. If the hole was too large, that would then be brought to the attention of health and safety, right, who would use like a bicycle repair kit and put a patch over it. If the hole was large, then we might just decide to retire the suit and issue another one.
And where do retired suits go? Is there a museum for them?
No, actually, typically they would come down for training purposes. Actually, a compromised suit is a great learning tool.
Yeah.
So, for example, whenever we learn in the training suits, the trainers have old suits but small holes, and those holes are really small, and we have to listen and learn how to patch the suits as well. That's an integral part of the training process.
Makes sense.
Yes, some holes are hard to find. In fact, we had one, what was it, under the arm?
Yeah, so whenever I trained with John just recently, they unfairly put one right underneath the arm, really hard to find in the visual inspection, but whenever you blow it up and inflate the suit, you hear tss, and you know there's a hole somewhere, and then you find it, tape it, take it all off, and make sure that the suit inflates and holds the pressure the way John has shown you.
What about the gloves? Are they more easily replaceable if there's a hole in them?
Yes, they are. As you see, there's tape on the gloves. It's really important. We can't have compromise of the gloves. We do have inner gloves, and you'll be donning those shortly, just in case there is any little pinholes that develop in the gloves. You're still protected. One of the most important things after testing the suit, as many will attest, is to remove these.
What happens if you left those in and...
This is what happens, Vince. You go like this. And the problem is, you have to get a buddy to unplug you.
Because you can't reach the plug.
Once you're like this, you're not going to be able to pull that out very
You cannot get your arms down.
So that's happened, I suppose.
It's happened, and it's very good. It's a very good thing for people to witness. You know, it makes you extra vigilant.
I'm sure the people who see it are very
You absolutely, Tim, never to forget to take the tape off. You've done it once, yes.
Has it happened to you, Paul?
It has not.
It's happened to me.
Okay.
Yep.
So I have a question.
Yes.
Can I go now?
No, you can't.
You want to leave?
You're in for the duration. Okay, so now we've tested out the suit. We know that there are no holes, no other compromise. The next thing you would need to do is to put on your inner gloves and step into the suit.
Okay.
Okay.
Okay, so I'm all taped up. I've got the inner gloves on, and I see that people have kindly put on some outer gloves for me.
Right.
And I have a suit that says Dove on it, which is, I guess that's the one I'm supposed to wear. And I have perhaps stupidly volunteered to do this first.
Okay, and you've checked out those gloves, right?
Right, I've checked.
Make sure those don't have pinholes?
These gloves, I believe, would fit properly.
Excellent.
And they don't seem to have any holes.
Excellent. Well then, in order to get into it, you want to gradually introduce your feet in there, whatever's comfortable, whether you stand or sit to that. And slide your feet all the way to the end. And just stand after you've done that. Okay. So now you've got it about halfway up.
Right.
All right. You want to fit your left arm into the suit arm. And wiggle your fingers until you've got your hand all the way at the end of the glove.
I know.
Okay. Very good. Now the next part you're going to do very slowly because we don't want you to hurt yourself, okay?
That makes two of us.
You're going to grab onto this side of the suit.
Okay.
Inside of the suit.
Inside of the suit.
Right
oh,
there.
I see.
And ease your head into the visor head area. Good, excellent. Good. All right, I would recommend hooking up at this point, just so you have some air going to the head.
No, I don't think we should give him air, do you?
Okay.
Okay.
Okay, now you have to ease your arm into the, again,
other arm.
And work your hand all the way to the end. Excellent.
And then
Now typically we'd zip all the way, just zip halfway down. Again, there would be medical clearances. We haven't cleared, so don't zip all the way. Excellent. Good. You're in. Very good. Stay on air. Stay on air.
A word you're saying.
That's one of the problems. Because 60% of the air goes to the head, it's very loud.
Right.
And what we're experimenting with here is in-suit communicators, just so that we can hear between suits. So, work in progress.
All right.
So once in containment, it's really important that the suit wearer puts on a pair of protective boots. These are the boots in question, hazmat boots. And the reason being is that the feet on the suit are smooth. There is no traction. Besides which, the floor is quite rough. So the floor itself could damage the feet of the suit. It's really important also to maintain balance when putting these on. So I would recommend bracing yourself, backing up to a surface and putting them on. One of the first things we want trainees to do is learn to move around the lab, hooking and unhooking the hoses. And I don't know if you can see it in the shot, but these stretch quite a long way. If you release this, then you have a missile. This can injure your co-workers. It could injure biosafety cabinets, destroy them. It could sweep your agents off the shelf. So it's important when moving from place to place that you get comfortable being off air. So you would unhook, hang it up, move to the next hose, and hook back in. Yes?
How do I scratch my nose?
Carefully. Please hook up and just practicing moving from hose to hose. So feel free to move around, just hooking and unhooking. It's important to hang them up. Hang them up. So after simply moving around and hooking and unhooking, one of the most fundamental things is sitting down at a biosafety cabinet. Simple tasks like this in a suit are very difficult because you have the hose that's tethering you. You don't exactly know your spatial surroundings. It's important to hold on to the chair so that you know where it is, so that you feel it, so that you know there's something under you, okay? And then you ease yourself around to the cabinet. Know where your hose is at all times, because that can get tangled. You will notice that the air pressure goes up in your suit.
Right.
So it'll ride up. You need to expel the air a little, lean forward to feel comfortable, then push yourself into the cabinet, okay?
All right, I'm sitting down, I'm looking for the chair, I got it. I'm sitting slowly down and I'm expelling my air. It's beautiful. It feels great. I feel the back of the chair. Everything okay? And now we're going to turn to the hood.
Just be aware of your hose.
Yes.
You're sitting on the hose.
Yes, I sat on the thing. I sat on the coil. That's not good. All right. This feels pretty good. Coming up to the hood here. Eppendorf pipetters. Let's see if I can handle one of these. Not bad turning it. Pretty easy in these gloves. They're really pretty manipulable. We'll pick up a pipette tip. Now let's see if I can pick up a tube. Here's the rack. Here's a tube. Take off the top. Now this is going to be a little harder with this. Pipetting is not too bad. So the gloves are actually very manipulable. These are very flexible gloves. I like them. So let's see if we can stand up here. We'll feel the chair. I'm ready to go. I got my feet on the floor. And everything goes slowly in a BSL-4. And there you go. And here we are, we did it. We're now entering the BSL-4 labs from the suit room. As you see, we're no longer wearing our Chemturian suits. Because we've not received the full suit training, we're not allowed to wear suits in the BSL-4 labs. Fortunately, the BSL-4 is not yet functional, and we can walk through it in our street clothes.
So this is the central hallway. We've got labs on both sides, right? What's biomolecule production?
So actually biomolecule is my core. So we are going to grow viruses in this core, and we'll provide these viruses to the other researchers, and we will titrate viruses which we get from the other researchers. So it's all about growing viruses and getting some information.
What kinds of viruses?
So actually, of course, BSL-4 viruses, and with one exception, all BSL-4 viruses are RNA viruses, and this includes Ebola virus, Marburg virus, Nipah, Hendra, Crimean Congo hemorrhagic fever virus, Lassa virus, and a bunch of other viruses.
And they all are enveloped as well, right?
Exactly, they are all enveloped. So, and that's the reason why it is pretty easy to work with these viruses in BSL-4, because we can use the same inactivation methods for all of these viruses, which is kind of a little bit like HIV.
So after polio is eradicated, it will be a BSL-4 pathogen. Could you readily bring polio in here and work on it?
No, we couldn't, because polio is very, very different. So it's a nightmare to work with this virus because it's very, very difficult to inactivate it. So actually we don't want it here in the BSL-4, to be honest.
Okay, and so this is an animal room over here, it says?
Exactly.
Anybody in the group work with animals?
Yeah.
You do? Can you show us a little bit about the room?
Let's go in.
Let's go in. But there aren't any animals in here.
No, just us.
So Paul, this is an animal room. What would be done in this room?
This is the animal procedure room.
Procedure
Room. The animal holding room is in here.
You cage the animals there.
Animals are caged in dedicated HEPA-filtered cages if they're small animals, larger cages if they're larger animals. So we have the opportunity to work with a range of animals in this facility.
Give us some examples. What kind of animals?
Well, small. So lots and lots of experiments are done on rodents.
Right.
So mice, rats, hamsters are a really good model.
Okay.
And then you've talked a lot on TWIV about the ferrets.
Right.
An excellent model for influenza, for example.
For ferrets, right?
Influenza for ferrets. And then, of course, you've got non-human primates. Ultimately, if our goal here is to develop new vaccines, new antivirals, new therapeutics, the only way to test the efficacy, whether or not it works or not, of a new therapeutic is to have a model which you give the test vaccine, the test antiviral, and then you go in with the real disease.
So I'm getting a sense that a lot of this work is sort of modularized. You've got virus being produced by one team in one facility, infections by another team in another facility, so there's a lot of division of labor and cooperation amongst the different units, right?
See, it's so difficult. If you imagine the amount of training, so you've seen how difficult it is to put on a suit. That's a challenge, okay? And you only did that once. It takes a number of times for us to even get up to this floor in those suits. So you want to be able to divide that labour. So really good people who really know how to grow the viruses, purify the viruses, concentrate the viruses, all concentrated within biomolecular production. We don't do that. We don't do that. We do microscopy. So my vision for my core is to have it doesn't matter if we're looking at Ebola or Marburg or any of these other viruses, we just want to be able to do the best microscopy as a core. So that's me playing to my strengths. So it's not trying to do everything, it's just trying to do what you can really do very well.
This is very different from a traditional lab, right?
Of course.
Ron, roughly how many people would be working in this whole facility?
The facility is designed for a maximum of about 50 at any given time. It's more likely that there won't be more than 30 to 35 in the facility at any given point.
Okay.
And that's as we fully build out. And once we're given permission to go to BSL-4, it's going to take a few years to either recruit in or train in those individuals that can work safely.
So this is in comparison to other BSL-4 labs. This is huge.
This is a large BSL-4 facility, absolutely.
And the other positive, which you've mentioned, that it's not just a BSL-4, it's a BSL-3 and a BSL-2 all in one, which you said was unique, right?
Yeah, there's only, I mean, Galveston National Lab also has this model, and it's the big problem with BSL-4s is they tend to be isolated. So anyone who wants to do any BSL-2 work would have to go to a different building. And one of the nice things about this building is that so much of the support work for both level 4 and level 3 get done at level 2. And so here you basically have an integrated facility.
And an experiment that might require a BSL-4 component might very likely have BSL-2 and BSL-3 components as well.
So for example,
do the whole thing right.
Absolutely. So for example, why would you come in here and spend all of your time in this suit passing cells? You pass the cells, you make all of the preparation outside in that BSL-2 space that you've seen, and then you carry that in and you do the BSL-4 work in the BSL-4 environment, so that you don't have to spend all of this time in the suit, so that you don't need to do that. You do the appropriate experiments in containment, and everything else it's logical to do.
You can't do that if the BSL-2 is downtown.
Exactly. Exactly.
Can we continue walking down the hall and look at more rooms?
Sure.
What of interest is next here, Ron?
Well, as Paul was talking, about doing animal modeling,
Right.
one of the ways, one of the things that we wanted to bring to this facility was the ability to do research in animal models in ways that people in containment have never been able to do. And that means bringing in animal imaging as part of the component of the work. It's a non-invasive way that you can watch the pathogenesis go on, and it just adds to the knowledge base that we have. So the first stop here is an MRI. It's the only functional MRI that I know of that's been established in containment in a BSL-4 laboratory, and it'll actually allow us to image animals that are infected in this facility.
I have a question about the setup of the whole facility. So we're walking down a corridor here. The whole facility is contained, right? We're in spacesuits, and yet the individual rooms have doors on them, so that the individual rooms are contained themselves. Why do we need the additional containment of individual doors on the rooms if the whole building is?
There are a couple of different reasons. So one of them is because if you're using different pathogens, you want to keep them segregated. And so keeping them within rooms and closed is necessary for that. The other reason, it's a very practical reason, is that this allows you to segregate each room by itself, decontaminate it without shutting down the entire facility. And one of the advantages of having a facility of this size is it allows us to work with several agents to cycle new experiments in and decontaminate rooms without having to close down the entire facility as part of that.
So, can we see some more labs?
Sure.
So Ron, up on the ceiling there are a lot of metal structures like that. What is it?
Yeah, we have, if you notice, we've got this one and then we've got another one here. So these are air intake and exhaust, and both of them are fed through HEPA filters on the deck above us.
All right, so above this floor, above where we are, there's an entire separate floor full of air handling equipment.
Absolutely.
And those have the HEPA filters which will filter all the particles out of the air.
That's correct. So that any air that exhausts out of this facility is sterilized before it's released.
And on the other hand, air coming into the facility comes in on the floor above, is filtered.
It comes in from the outside, pulled in through the floor above, and it's filtered out.
And comes in through the ceiling here.
It comes in through that, right. And the rationale for that is that if for any reason one of these facilities went positive and started pushing air out, then it would be filtered no matter which direction that it was released through.
Okay.
Can we see all that air handling stuff? Can we go
No,
up there?
absolutely not.
Oh, come on, please.
Well, if you insist.
Okay.
Oh, so this will give you a great idea of what happens to the air that's coming out of this facility.
Okay.
And it also gives you a good shot of the so-called box within a box.
Ron, I've been working in microbiology labs for years. I've never seen anything like this. What is this?
Yeah, this is a very unusual space because to support a level 4 laboratory, you need to HEPA filter the air in and HEPA filter the air out. And essentially what you look at when you look across this floor are the banks of HEPA filters that are required in order to support that BSL-4 space. The hissing that you hear in the background is part of the compressor systems that's used for the piped-in air for the people working in the level 4. And this is really one of 2 floors that supports the containment space in this building.
So this facility covers the entire size of the building, essentially, is that right?
It covers most of the size of the building. Remember, this building is basically a second building inside the main building. And when we walked in, there was this plate.
Right.
That plate covers the gap between the ceiling that we're standing on, which is the ceiling in the level 4 space, and the rest of the building, which is the perimeter of this space.
And what do these red stripes on the floor mean?
So the red stripes actually denote the room demarcations for the space below here.
So there's individual filter units for every room?
Each room is a separate isolated unit so that you can actually either close that room off and decontaminate it. You can close off the filter sets and decontaminate them and replace them. And the idea is that way you don't need to take the whole BSL-4 down if you need to take down a room.
So the air is taken from the rooms, it's filtered up here, and then where does it go?
It's exhausted into the atmosphere.
And then the air that goes into the facility comes from here in this room?
Comes from the outside.
And it's filtered?
Brought in, HEPA filtered and put in. And that's just that protection in case under any set of circumstances, a room goes positive, that you've got a filter unit that's going to collect anything that happens to be in that room. So that's one of the differences in the requirements between BSL-3 and BSL-4.
And HEPA filter takes out, does anybody know what HEPA stands for?
High efficiency particulate air.
Very good.
Yeah.
And then periodically somebody's got to, what is maintenance, okay? They've got to decontaminate them or something?
Change the filters?
Yeah. So each of these filter units are set up with ports. These ports are there for computers so that you can measure efficiency in these units while they're in place and running. But if you do have to take any of these filter units down, they all are set up so that you can close them off from the room below. You add vaporized hydrogen peroxide to them so that you can decontaminate them in place. And once they're decontaminated, then you can remove a HEPA filter and then put a fresh HEPA filter in and then reactivate the filtration system.
So aside from these HEPA units, and there are a lot of them, there's a lot of other stuff here. There are all kinds of vents and piping.
It's like a lot of plumbing.
What is it for?
There's a lot of plumbing. So a lot of it is HVAC that goes into the system, to the rooms downstairs, because they are, you have to cool the air that goes through the filter sets. You see a lot of the electrical units that are part of it. One of the issues with level 4 labs and level 3 labs is that you always need backup electrical systems. And so that complicates the facility and also makes it more expensive to have built. So we have 3 energy feeds that feeds this building from 2 different substations. Any one of those can run this entire building. So, we all know that we have snow in Boston, and it's one of the real issues is when the power goes out, what are you going to do? So if the power goes out in one substation, we have a feed from another substation. If that goes out, there are 2 generators on the roof. Either of them can run this entire facility, and there's enough fuel on site to run the facility for 72 hours fully loaded. And what that gives you is time to come in and bring the place down safely.
And then, of course, you have additional compressed air as well.
Yep.
So you need to have additional electricity backup measures, additional compressed air backup measures, and those tanks are just over there.
So this is an unusual look at a facility like this. It's not often that you can go through and do what we're doing today.
Well, it also gives us, I think one of the things that we have learned going through this process is that you cannot over-communicate with people outside of a facility like this. That it's really important to continually find different ways of communicating what goes on in here and try to give them some sense of how safety and security is handled in a facility like this, and the fact that people like Elke, who have almost 2 decades of experience now working in level 4, feel quite safe in doing it. And after all, the people on the front lines are the ones that are most at risk.
It's even a little bit more because we already talked about this concept of having a building in a building.
Right.
So if you think about an earthquake, there is no place safer in Boston than this building here. So it gives a pretty good feeling. And yeah.
But not on the roof. You have to be inside.
After visiting the air handling floor, we moved to the microscopy suite, where Paul is responsible for cell and tissue imaging. He will use state-of-the-art static and video microscopy to understand how viruses move within an infected animal. While we were visiting the microscopy suite, we noticed a sink with very thick pipes. We learned that these are very special pipes within a pipe that contain sensors for detecting leaks. The liquid moves from the BSL-4 lab to large tanks on the first floor where the material is boiled under pressure to inactivate infectious agents. In a BSL-4 lab, all material is inactivated both at the sink and in the cook tanks.
So Ron, where are we here? This is quite an interesting room. Or what do we have in my hands?
Yeah, well, you're holding a very expensive piece of metal piping, I can assure you. And so these are double piped throughout the building,
right,
so that you can have sensors inside of them. And those sensors are there to tell you segment by segment whether or not there has been a breach of this waste pipe. And that way we get an alarm if that occurs.
So every pipe in the building looks like this?
Every pipe out of the BSL-4 looks like this.
And they're not all this diameter, I presume. They're different sizes?
Well, all the pipes that come out of the sinks and out of the drains in the BSL-4 are this diameter. And once it's not observable directly, it's always this double diameter piece of stainless steel.
Okay. And so the sinks, the drains, the chemical showers, they all would go into this?
They all drain directly down onto this floor.
And what about the toilets?
Well, unfortunately, you can't go while you're in the BSL-4, and so there are no toilets in that level 4, and so they go through the normal waste.
Well, what if you're 2 hours into a procedure and you have to go? What do you do?
Well, you either hold it, or you scrub out, go to the bathroom, and then resuit and come back in.
That was done purposefully?
To be cruel?
No, leaving out the toilets.
Yeah, that was done purposely.
No BSL-4 has a toilet.
No BSL-4, to my knowledge, has a toilet. Yeah,
so all this water, waste, or fluid comes to this room, and what happens down here? It comes down to this
room. So, you know, this is like the this is that N+1 type of philosophy where you inactivate something and then you bring it into a place and then you re-inactivate it. And we do that all the way throughout the facility. So all the the water that would come down into this
tank,
thank you. So it comes down into this tank. Once this tank is filled, then the water is then switched to another tank.
Okay.
Okay, so you see we have three tanks here.
Yep.
Right? So you always have one that's being filled, one that's ready to be filled, and then there's always one as a standby in case there's any problem with either of these two tanks. Once a tank is full, it's shut off, and it runs essentially like an autoclave. Heat, pressure, and then you do spore strip tests to ensure that you've actually killed everything in it. And once that's done, then it can go out the normal waste stream, which goes into a neutralization tank and then out in the waste.
So how many gallons does each tank hold?
These are about 1,500 gallons.
So during normal operation, would you expect that to fill up rapidly?
That's a very good question, and actually we're not going to know the answer to that until we start working in the facility.
So you have 4,500 gallons capacity here, essentially,
we do.
right?
We do.
So if you have a
problem, we would expect this not to fill up more than, you know, once a day to once a week, depending on how heavy the use is.
Right.
And most of the liquid waste actually comes from the chemical showers.
Right.
So it's really dependent on the number of people that are coming in and out of the facility.
It's an unusual room. Never seen anything like this.
Yep, you don't see them anywhere outside of BSL-4 laboratories.
Speaking of BSL-4, should we go back up and finish up?
Let's go. Here. I'll take your paperweight.
Ah, thank you. Heavy. So Ron, this room has the descriptive name liquid nitrogen freezer storage. You can guess what's in there.
Yeah, well, it's freezer storage for sure. We have minus 150 degree ultra low freezer in there. One of the challenges with working with any agents, particularly select agents, is careful inventory. And so one of the things that we have to be able to do is account for every bit of a pathogen that we would use in a facility like this. It's an expectation of the Centers for Disease Control, it's an expectation of the laboratory, it's an expectation of Boston Public Health. So we barcode everything carefully, identify what volumes we have of it, how we've stored it, and then when some of these samples are checked out to an individual investigator, then they become the individual that's responsible for accounting for how they've utilized that pathogen. And all of this has to add up at the end, and CDC is allowed to come in and make spot inspections at any given time and really ask to double check the inventories and make sure that they can see what's happened with the pathogen.
So does everyone have access to this?
No, this is a limited access room, and there will only be a couple of people that are allowed to get to the master stocks.
So your Ebola stocks would reside here, and if you want something, someone would get them and give them to you.
Yes,
And then you'd bring them to your biomolecule lab and propagate them.
Exactly.
That's how
And
it
then I
would
would
work.
hand
There
them
wouldn't be-
over to Paul for his exciting experience.
Microscopy.
There wouldn't be any storage in the individual laboratories, all the storage is here?
The core storage is here. There's short-term storage in the individual laboratories for ongoing experiments so that you can use a single stock for an experiment.
And if you grow more virus, you add that to your inventory and account for it.
That's right.
And then if it's a master stock, it'll go back in.
Right, okay.
So the master stocks are generally done here from specimen processing. This next room is responsible for identifying and cataloging the master stocks.
Let's take a look at that. This is sample receiving. Ron, you going to tell us about this?
Yeah, this is sample receiving and specimen processing. So this lab serves a couple of different functions. One of them is when a new pathogen is brought into the facility, it would first come here and be cataloged and verified.
So this is a known pathogen.
This would be a known
right?
pathogen.
Okay.
It is almost impossible to believe that we'll ever get an unknown pathogen into this facility because they all have to go through CDC first.
Okay.
It would at least give us some indication of what we're dealing with. So anything that's shipped in here, we'll know what it is, what the volumes are. They all get verified in place here before they get put into central storage or go into biomolecule production for expansion. And the other function that this particular course serves is specimen processing. So specimens that are being brought from, say, animal studies would be brought into here and prepared to be distributed to investigators or for other cores to do their functions.
So you say an animal study done outside or within the core?
No, within the facility. Within the facility, absolutely.
Okay.
So we have to have, again, it's this core, vision of having people that are expert in dealing with samples so that every investigator doesn't have to kind of relearn the tools of the trade of each individual process.
So who's the best person at getting you RNA from blood?
Or getting you blocks, or getting you blood chemistries, yeah. So blood chemistry work gets done here.
So would there ever be a situation where, say, there was an outbreak somewhere and you received samples from, say, people from the outbreak, or would that have to go to CDC first?
Currently, it'd have to go through CDC. And it kind of just depends, I think, on the time and any changes in what the current law is.
But for CDC, you're a resource, so they would use you if necessary,
Yes.
or if they wanted to do that.
Yes, well, we certainly hope so. I mean, that's where we're going to get some of the more interesting samples is from new outbreaks. And I think, part of the things that Paul and Elke both have emphasized is that you really want to deal with the right virus. And if you're dealing with the right virus, that means the one that is as close to the human outbreak form that you can possibly get.
After you're done working in a BSL-4 facility, it's necessary to take a chemical shower. The chemical is a disinfectant that ensures that no contaminants leave the laboratory. You walk into the shower with the suit on, take a 3-minute chemical shower, followed by a 4-minute rinse, and then you exit on the other side. We haven't been through the training needed to do a real chemical shower, so during our tour, we just walk through the shower room.
Well, guys, this is where we say goodbye. We want to thank you for being great hosts and for showing us this incredible facility.
Yeah, it was a real pleasure.
Thank you so much.
Glad you took the time to come.
My pleasure.
Yeah,
It's been a lot of fun.
Thank you so much.
It was a lot
Elke,
of fun.
pleasure.
You performed very well.
Good seeing you. Thanks for the
Nice to
seminar
meet you.
that we didn't hear.
Thanks for the
All
Safe
right.
home.
All right. Here, we'll let you out.
Rain.
What a great tour that was. We visited the NEIDL here in Boston, Massachusetts, a facility that contains high-security labs like a BSL-4 and a BSL-3. We had a unique look at the kinds of measures needed to keep a BSL-4 safe, like perimeter security. We saw how you suit up and move around in a 4 lab. We saw how you work within a BSL-4, and all the precautions that are taken to make sure that the air, the liquids, and the solids are handled properly. This is truly the best place to study highly dangerous pathogens. And not only will it help us to develop antivirals and vaccines, but it will also contribute basic information about viral pathogenesis. It's truly a remarkable building, and it's no surprise that Elke thinks it's the safest place on Earth. Soon after our visit, the NIH Blue Ribbon Committee found that the safeguards and engineering controls in place allow maximum containment research to be carried out safely at the NEIDL. Although other legal hurdles remain to be overcome, the NEIDL could soon be fully functional.
Do you have boilers here? Chickens?
No, that's broiler.